Alrighty then. Now, we're going to do stuff out of the workbook. And remember I said that you're probably going to see triangles that are not set up the way I normally set them up. Well, the first thing they do is they say, okay, learn to recognize these triangles sitting in different ways. So let's go to the very first problem in chapter 14 of the workbook. And it says, find the sine, cosine, and tangent of x. Okay. So let's make a little list here. Oh, hell. I can't hear you. Thank you. That was terrible. One more time. Now, when you guys hear this in the recording, you're going to go, gee, that was really weak. One more time. Well, that was better, but that was still pretty weak, but okay. Okay, so let's find, if we're going to call this the angle, let's not do that. Let's go to the other side. Let's call it Z. Okay, if we're looking at Z, now your homework's to do X. Let's do your homework. Got to be some benefit to this stuff, right? Okay, so the sine, okay, if this is our angle, first of all, we know that this one's got to be the hypotenuse because it's the longest one, right? So we're going to call that H, right out of the bag, right? Whoop. I'm going to shake my computer off the desk. Let's move it over a little bit. Sorry. Okay, so we know that's H. Now this is our angle. So the side opposite is that one over there, we think, right? So we think this is the opposite. So that leaves this one is adjacent because it's next to it. So that's the adjacent. So we've figured this out, right? So O over H is 4 over 6, right? Okay, cosine. The adjacent, which is 3, over the hypotenuse, which is still 6. So the cosine of theta is equal to, and then the tangent. Now this is where it's tricky, and you have to say of agony. So the opposite is 4, and the adjacent is 3. Here we have another example where the tangent is a number larger than 1. It's 1 1/3, right? Okay, so that's the first homework problem. Let's get rid of this. Okay, now let's look at this next problem. Where did I grab that? Oh, if you go to problem number 3, part F, you have a triangle that looks like this. It's 11, 15, and 12. And it says calculate the sine, cosine, and tangent of the angles named in each triangle. So which one is named in this one? This one has a letter down here, Z. So this is our angle. Well, if that's our angle, then 11 is our opposite, right? Everybody see that? Okay, which one's the longest one? We know that's the hypotenuse without a shadow of a doubt, right? Because it's the longest side. Okay, there's only one angle left over, and it just happens to be right next to angle Z, so it's adjacent to the angle, so that's our adjacent. So all we have to do now is the sine theta is opposite over hypotenuse. Our cosine is adjacent, which is 12. Is that right? Yes? Over 15. And our tangent, this is the one where you can go wrong, so you want to be more careful with this one. Oh, hell, another R of agony. Opposite, which is 11, over adjacent, which is 12. 11 twelfths happens to be smaller than 1 for once. Now, just for the giggles, shall we say, what angle is that? We could find that out from any of these three things, right? Pull out your calculator, hit clear twice. And now put in second function sine 11 divided by 15. Enter. Okay, hit clear twice. Now I want you to hit second function tangent 11 divided by 12. Enter. Say again. What do you mean 42? You mean we get different angles? That shouldn't be, should it? I wonder why that is. Am I going to answer that question? There you go, thinking again. Okay, let me hit pause for a second. All right, here we go. All right, let's go to another problem in your book. And one of them is really simple. It just says, find the value of the following. What is tangent of 4 degrees? Just tan 4, enter. .06999. Okay, cool. All right. And then we have another question where we have a bunch of questions where it says, find the number of degrees in each angle where tangent of I is equal to, in other words, the tangent is 1.1106. What angle is it? So we want to go hit clear twice. Second function tangent, bless you. Second function tangent, 1.1106, enter, and it tells the angle. 47.99, almost 48 degrees. Okay, very close to 48 degrees. Now, one more. It says find the number of degrees in each angle, and I don't want to do another tangent, so let's find the angle that has the cosine of 0.6109. We've done that before, actually, so hit clear twice. Hit second function, cosine, 0.6109, hit enter. 52.345. I wonder when we did those two angles where we have the odd numbers, I wonder if that triangle would have worked out. It doesn't work out, does it? Those are just random numbers that aren't really a triangle. That's why it doesn't work. Aren't you glad you figured that out on your own? You are brilliant, I tell you. Okay, let's go to another problem from your homework. And, oh, I like that. Let's do that one. Let me see. There's lots of fun problems in here. Let's do. Let me hit pause one. Okay, we're going to look at somebody else's use, not just electrical use, of triangles. It says calculate the angle between the roof and the ceiling joist in figure 15.5 or 15-5. The rise is 2.75 meters and the run is 5.67 meters. Okay, so let's just say that we're going to call this corner over here the angle. Would that be okay with everybody? And so now we have a name for the 2.75. What is it? That's the opposite, right? It's opposite our angle. Okay. Okay. So we have our little reminder up here. And as we're looking at this, what two sides do we have? This is the opposite. And what side is this? Adjacent, because we know this is the longest one, right? So we have the opposite, and we have the adjacent. So as long as we're careful about which one is the opposite, we can say that our 2.75 over 5.67 pardon me, is equal to the tangent of this angle. Okay, so all we have to do is hit clear twice and put in 2.75. No. Hit clear twice. We want to hit second function tangent. Tell me what angle has this tangent, and then 2.75 divided by 5.67. Hit enter. How many? 25.873. 25.87 degrees. Almost 26 degrees. Not exactly, but almost 26 degrees. Okay, so you can see that triangles affect everything. Like one of the things you're going to do one of these days, you're going to be building your own house someplace. Or you're going to be building a house. Now, I have an odd question for you. Let's just say we know we've got this rectangle that's the basic square pad we're framing up. And we think we have it square, right? Let's say this is 27 feet long, and this is, what, 18 feet wide? And we think we have it squared up. How do you think? Now we've got a wooden frame around the outside edge of this thing where we're going to pour the concrete, right? How do we check for squareness? Right. Now, what should we expect? Can we just measure it and see if the two are the same? Yeah, that might work. It might just be so screwed up that both are the same, but it's a parallelogram, and it's way out of whack. So if we know what to expect, that's kind of a key thing in troubleshooting, is knowing what to expect. So let's say that, let's pick a side. Let's pick one over here. We're going to say that over there is our angle, right? Okay, so now we can say that this is the side opposite, this is the side adjacent, right? What function do we have? What are we looking for? We want to know the hypotenuse because we need to know the inside of this wood corner to the inside of this wood corner has got to be exactly that or we're off, right? Okay, so let's find out. So our angle we have to find by second function tangent, and oh hell another of agony, 18 over 27. What angle do we have? Hit clear twice, hit second function tangent, 18 divided by 27, enter. Degrees, and now we want to have the what? Do we want to have the sine or the cosine? Either of them will work, right? Let's use the cosine. So just hit cosine, second function, answer, enter. And the cosine of that angle .832. Okay, 83205. Now, if we have that, then 8.3205 is equal to A, which is 27, divided by H. So if we just switch these two, we're going to wind up with what? H is equal to 27 divided by 0.83205, and that long number that's in your calculator already. So we're going to just enter 27 divided by second function answer, enter, and we find our hypotenuse should be what? Okay, we come back to that problem again. What is 0.44 feet? What is 0.44 feet? That's not 0.44 inches, by the way. That's 0.44 feet. So first, we have to multiply 0.44 times 12, right? So 0.44 times 12 is what? 5.28. Okay, so what does that mean? 32 feet, 5 inches, and what? 28. Now, 28 is a fraction of an inch, right? 0.28. Now I want to divide by 0.0625, right? I want to get rid of the 5, so minus 5. Am I left with 0.28 now? Divided by 0.0625. 4.4, a little less than 4.5 sixteenths. 4 sixteenths is 1/4. So what are we going to say about this? So when I yell to the guy that's taking the tape measure on the other end, I'm holding it down here on the dumb end, as they say, and I'm going to yell to him and I say, it's got to read 32 feet, 5 1/4 strong. In other words, just a little tiny bit past 5 1/4, right? Half of a 16th, a 32nd of an inch. How wide is a pencil lead? About a 32nd. So if you put a mark on the back side, you're going to be right on the money, right? So if I have to, now, if it's that, I know I didn't have to take a second measurement. I know it's square. That means that this over here is a 90-degree angle. And this over here, and this over here, and this over here. It's all squared up. So now, you guys can lay concrete. All right.